Hello everybody. Hi. Today we're going to talk about a question that's there in Leetcode. It's a quite famous question that probably asked in multiple interview rounds. It's remove duplicates from sorted array 2. Instead of explaining the problem statement over here, let me give an example and explain the problem statement and gradually deep dive into the solution of it. Yeah. So let me start it off. The problem for this particular question says that you have an array which can have multiple duplicates. Now you have to make an in-place operation. You understand in-place operation in the sense that you cannot use a space complexity of O of n. Let's say n being the size of the array. You cannot use an additional space complexity, right? Um, and you have to work on the original array itself, making in-place stitches and operations to modify it, but the array size doesn't shrink or expand. The array size, let's say, had 8 elements. Finally, it'll still have 8 elements. The thing is, there are initially duplicates, right? Let's say there are 5 duplicates, 5 ones, and then there are like 6 2s and 7 3s. What they want is, I can I can at most have 2 duplicates of a single element, right? Not more than two, provided also this is also mentioned in the question that the array is initially sorted in a non-decreasing order, meaning in an increasing order: 1 1 1 2 2 2 3 3 3 4 4 4, or 1 1 1 7 7 7 8 8 8, like that. It is increasing, right? But the only catch is you have to do the entire operation in place. You cannot have an auxiliary time complex space complexity of O of n. That's one. The second point over here is a unique element cannot be repeated twice, more than twice. It can maximum at max be repeated twice. So, if you understand this, then I would assume you understand an example like this. You have this element. What it says is, how many elements do you see right now? I see 7 elements. The size is 7. The final size would also be 7, right? But you can only have the first two repetitions of the value 1. You can only have two repetitions of the value 2. And what about the remaining two ones? Well, push it back. What about the single 2 that's left out? Push it back. Right? You're only, or the interviewer is only interested in the first part of the array. First part in the sense, this part of the array, right? And this part has how many elements? 4 elements, right? So you return 4. So from your code, you return the size of the first part. For this example, it is 4. What are the conditions? The array is sorted in an increasing order. You have to do this operation in place. The relative order shouldn't change. Relative order in the sense, this is 1 1 2 2. Interview doesn't want to see 1 2 1 2, right? This is like the relative order is changing. The one subset is before 2. First comes the entire set of 1, then comes the entire set of 2. You cannot shuffle it out, right? So that is like that, you can't do that. So how about thinking about a solution? Let me now try to create a concept, create a, you know, a concept of seed inside your head, and let's see if that, is fertile enough for, growth. So if this is my input array, and try to, keep an open mind, because DS algo, usually mind gets cluttered with over information and we fail to give out our best in an interview round. So that's the typical challenge of a data structure problem. Since it said that the space complexity cannot be of and I have to do a in place operation. So initially I make a claim that, hey, probably this is a pointer approach, 2 pointers approach. It might not be a 2 pointers approach, but this is my initial claim because of the fact. The logical reason is I cannot have a space complexity of O of n. I will have 2 pointers, pointer 1 and pointer 2. I'll call them fast and slow for my convenience. Fast is because fast will usually move ahead. There will be a, although fast and slow initially would start from the same index, but after some time, I would assume that would stay behind and fast would move ahead. Why? Because there would be certain conditions. And the second part is I would need a variable called counter. Counter. This is essential to know that how many repetitions of a particular element I have captured thus far. What does this basically mean? Let me try to explain. It's in very layman terms, it is the number of occurrences of the element pointed by f, or the fast pointer. Number of occurrences of the element pointed by f. Now, my example: 1, 1, 1, 1, 2, 2, and 2, right? I would say my fast pointer and slow pointer both would be at here, initial. Index wise, this is 0 index, 1 index, 2 index, third. Why I would keep it here? Because I would like to make comparisons with the before element, right? If I start with 0, if I start from index 0, there's no element before index 0, right? So I don't want that. That's why I started from index 1. Okay. Also, what happens if this array, let's say this array is ARRAY, its length is not more than 2, it's less equal to 2, what would happen? You could say, one, there's no element at all, the array is empty. Okay. Let's say the array is empty, I don't have to do any operations, there's no logic to implement over here. Cool. What if the array element is 1? Array element, as length of the array is 1. It could be any one element. It could be 1, or it could be 2, or it could be 100. Only one element. So in this case, what do I need to do? I don't need to do anything. There's no logic to implement over here. So what am I returning? I'm returning the size of the first part of the array. Here, the size of the first part of the array is the entire array itself, right? What about array length being 2? If there are two elements, for example, if there are one, if there are these two elements, 1 and 2, you know, there can be a unique element that can be repeated at max twice. One is present only once, so this element is acceptable. This element is only there once. There's only one occurrence of the element 2, so this is also acceptable. So all in all, 1 comma 2 is acceptable. So if the array length is 2, then you can just return this entire array, I mean the length of the entire array, right? What about if these two elements were duplicates? If it was 2 comma 2, you know, according to the problem statement, you can have at max 2 repetitions of a single element. This element here is 2. How many repetitions are there? 2. This is also acceptable. So you don't need to do any logic for this, neither for this. So if the array length is less equal to 2, you just return. I'm trying to write in a very bad way. Just try to understand. Just return the array dot length and be over with it. The problem comes when your array length is more than 2. If it is 3, 4, 5 and beyond, I will initialize my fast and slow pointer over here, right? I'll make a comparison with respect to fast pointer. With respect to first pointer, I will say that, hey fast pointer, you're pointing to this element. Compare yourself with the element right before you. So fast pointer is looking at element 1. The element right before fast pointer is also element 1. So right now, the counter variable will initialize it to 1. But right now, since you have found two occurrences of the element pointed by fast pointer, two occurrences of the element pointed by fast pointer. Fast pointer is pointing to the element 1. How many repetitions of 1 you have seen thus far? 2, right? 2. This is repetition number 1, this is repetition number 2. That is why counter got incremented to 2, right? Okay, this is, you can have two repetitions of the value 1 of a single unique element. So this is acceptable. What you say is, hey fast pointer, slow pointer, both of you move to the next element, and I will take an eraser right now and I will remove this. Cool. Now what I will say that, hey fast pointer, you are pointing to this element. Compare yourself with the element right before you. That's also 1. Cool. So right now, can you tell me how many occurrences of the element pointed by fast pointer? Fast pointer is pointing to element 1. How many occurrences have you seen so far? 3. 1, 2, and 3. So counter increments itself to 3. Now there's a problem. According to the problem statement, the problem statement said you cannot have three continuous repetitions of a single element. At max, you can only have two. So this is a problem. I cannot have this one right now. So what I will do over here is, this is why your slow pointer is named as slow pointer, because I will tell slow pointer, hey, now you stay over here. Fix yourself over here for the time being. Don't move. And I will tell fast pointer, please move ahead. Right? Now, can you tell me what is the element pointed by fast pointer? 1. What is the element before fast pointer? That is also 1. So thus far, how many repetitions of the element 1? 4 repetitions, 1, 2, 3, and 4. So counter increments itself to 4. But I don't want 4 repetitions of 1, right? I don't want, I can't have. So I will say, hey, fast pointer, no worth, move ahead, right? Now, here, somebody from the audience, I can't see the audiences, but I'm expecting somebody might think that, hey, you have done the solution, that's why you're so pretty dang darn confident and saying I'll move fast pointer. How can you be sure? You're right, I can't be very sure. I'm just making assumptions and I'm thinking it through, right? I have done the solution, but when initially I thought about the solution, this is the same thought process that came into my mind. I'm not so futuristic to think and confidently say that yeah, fast pointer should move, but I'm making small assumptions. Let's see what happens. Fast pointer can't stay over here, right? And slow pointer can't move. Slow pointer can't move because this is this one, and any one that's coming after this is not desirable. I can only have these two ones and that's it, right? So slow pointer stays here, fast pointer moves ahead. Now I'll make a so eraser. I know this is irritating, guys. I can't hear you, but I'm assuming that you're also saying, ah, what an irritation. Please bear with me. So this is first pointer. Now first pointer is pointing to the element 2. The element before it is the element before it is element 1. Both are not same. What does that mean? It means finally first pointer is now landed up on a new element. New element. So what does the counter reinitialize itself to? It was 4 previously, meaning there were 4 repetitions of the element 1, but now first pointer is pointing to a new element, the element being 2. How many repetitions of 2 thus far? Only 1, right? Now what you will do is, hey, please copy this 2 and paste where slow is. Slow is pointing to index 2, index 2 had a value 1, now this 2 will come over here. Let's take a pause and give me a moment to write this entire thing again. 1, 1, 1, 1. It was initially 1, 1, 1, 1, 2, 2, 2. Isn't it? Index wise 0, 1, 2. This is where your fast pointer was. This is where your slow pointer was. Your counter at this stage is what? If you say 2, I'll be very disappointed. It is 1 because counter is always reflecting the number of elements you have seen, the number of the number of occurrences of the element pointed by fast pointer. Fast pointer is pointing to the element 2. Thus far, how many repetitions of 2 you have seen? Only one, only this element, right? Now this comes over here, so this 1 now is no longer 1, it is 2, right? And when it is 2, just think about this section alone. What do we have? 1 comma 1 comma 2. This is a part of my output which is acceptable, isn't it? Two repetitions of 1 is acceptable. Single repetition of the element 2, this is also acceptable. Correct? I'm gradually going towards the solution. So I'll move my slow pointer here from here. So instead of crossing this and making this a hideous image, I'll remove this. Okay, fine. When I'm over here, mm, my fast pointer would also increase. So this is no longer over here. So I'll again take my eraser. Right? Again the same question. Same question. First pointer, you're pointing to the element 2. Just before you have an element 2. So what is the counter value? Counter is the number of repetitions of the element pointed by first pointer. First pointer is pointing to the element 2. How many repetitions of the element 2? There are 2 repetitions. So counter increments from 1 to 2 right now. But I would need to copy this over here as well. Right? So this one would no longer be 1. This would be 2. Right? And then my slow pointer would be over here and my fast pointer would be over here, right? So eraser again. Ah, come on, I didn't pick the eraser. So now what is my result right now? My result is 1 1. Third one has been replaced with 2. Fourth one was replaced by 2, and then you have a 2, which is where currently the slow pointer is at, and then you had a 2, and then you had a 2, and this is where your fast pointer is at, right? Now the same question, hey fast pointer, you are at this element, your previous element is also 2, so what is the counter value right now? Counter value, without even looking at the counter variable right now, what does 2 represent? 2 represents the number of repetition of the element 2, the number of repetition of the element pointed by the fast pointer. Fast pointer is pointing to the element 2. Here's the confusion, right? You could look at this array and give a misinterpreted result. You could see, I can see 1, 2, 3, 4, 5, 5 occurrences, but no, that's not true. That's not true at all. Because remember, these two twos you have copy pasted over here basically. So when you say, when your fast pointer is over here and I ask you how many repetitions of the element 2, if you say 5, this is wrong because these two has been copied over here. So these two are actually non-existing. Non-existing. So don't count it like that. Look at the counter variable. Counter variable was 2. So now the counter variable increments itself to 3 because actually now you can see there are 3 repetitions. 1 repetition, 2 repetition, 3 repetition. Not 1 repetition, 2 repetition, 3 repetition, 4 repetition, 5 repetition. Not like that because these two have been copied over here. Just treat them as non-existing yet existing, but they're actually not existing. Yeah. So this is where your two is right now. So what you do over here? Do you copy it over here? Your counter is 3. Since your counter is 3, you say, hey, I can't have 3 twos right now. Slow, you stay over here. Fast, you move ahead. So fast moves ahead. I need my eraser right now. But fast has reached the end of the file, no, end of the array. Uh, end of the array, right? This is end, no more. So now what is your output? Your output has 1 comma 1 comma 2 comma 2 comma these two that I have just crossed. I'm telling you in your mind to understand that these are not existing, but in the array these are actually existing. 2 comma 2 comma 2, right? These are actually existing. So this is your desired output. I said you have to return the size. The size is 4 and your slow pointer is over here. Index wise, this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. Return the value stored at slow. Slow is pointing to index 4, which is actually the length of the first half of the array. If you just return slow, it should work. This is the concept of the entire problem. This is how you should approach. But then take a thinking pause, capture this end, and try to write it in an if else block. That's all there is to it. take multiple pauses of this video and try to write it in an if-else block. If you could do that, good. If you can't do that, take a pause again and try again. Giving a solution, writing a pseudocode comes much later. Building a concept based on looking at the problem and then thinking about how would I little by little make assumptions and write my if else code. The thinking that goes in your brain is something that's what I'm targeting right now. Yeah. I hope you enjoyed this video. Thank you.